Welcome to the Climate Gap Quick Cuts, a podcast for busy people building climate solutions. We spotlight founders, builders, operators, and investors doing the hard work behind real progress. I'm Ben, co-founder of Element 6. We connect climate tech companies with the people who make scale possible. Let's get into it. We know owners aren't chasing autonomous buildings because it sounds futuristic. They're chasing them because electricity is up a third, labor costs nearly 30%, and there simply aren't enough technicians to tune every plant by hand. In this episode, we cut through the dashboards and get into real control. What must an autonomous system actually read and write to be credible? What safety rails make closed-loop control auditable and trusted across a portfolio? And how do you show payback in one budget cycle without adding yet another screen to stare at? My guest today is Omar Tabba, Chief Product Officer at BrainBox AI, who has over 2 decades in HVAC, lighting, automation, and AI for the built environment. Let's get into it. Omar, welcome to the show. It's great to have you. Can you give an intro to you and your role, please?
Thank you for having us, Ben. My name is Omar. I lead the product team at BrainBox AI. I've been here in this role since 2019. I was an early, I joined early on in the journey at BrainBox. My background is, let's say, 20 plus years in HVAC, lighting, building automation, energy management, cloud and AI applications. So, happy to be with you.
We're very happy to have you. Thank you so much for joining. So the first thing I want to try and touch on is definition of autonomous. So what is the minimum credible bar for an autonomous building today? Specifically, what must the system be allowed to read and write for closed loop control to be real?
Yeah, so let's, we're a fan of plain language speaking, let's say here at BrainBox, right? So it's important that we're able to communicate what we're trying to do clearly. So an autonomous building is one that's able to observe, learn, and act on its own.
Yeah.
So popular analogies or common examples are a self-driving car, for example, that can navigate in the street by itself. So similarly, we want a building to be able to observe basically different data inputs, things like temperature, weather, energy, emissions, and so on, and then learn its own patterns and its own environment, and then be able to act, take a decision. So turn a fan on, turn a fan off, etc., so that it maintains the comfort that it was designed to provide while minimizing the energy consumption of that building.
Right. A nice simple definition. Thank you. So talk about minimum viable data layers within that. So data acquisition and normalization is topic number one. Beyond BMS points, which inputs matter most at scale, and how do you normalize them quickly without custom engineering at every site?
Yeah, this is a big topic, as you know, in our industry. So firstly, we need to start with the environment, right? So buildings are a heterogeneous environment. So we might have a Honeywell system in building A, a Siemens control system in building B, and so on and so forth. So different brands, different communication protocols, different naming conventions. So this heterogeneous environment basically makes it challenging to run standardized applications. So step one, whenever one would like to run a cloud application for the built environment, we need normalized data. So it's very important. This is something that we've developed internally here at BrainBox, is a dedicated tooling and team and process. People often focus on technology. We like to call it, the 3 Ps, right? So product, people, process, that are needed to take this heterogeneous environment and normalize it. So we give all data points coming in a standard naming convention. We tag them all with an open standard haystack tag is the one that we use. And that enables our upstream applications to consume this data irrespective of provenance. So now we don't really care as much where it came from or what specific communication protocol it was, because it's all enterprise data.
Yeah.
I can add maybe a couple of more things. So I mentioned, some building automation system data inputs, which is definitely a key ingredient. We need to know the temperature, the fan status, etc. However, there's a lot of other very valuable information that is needed to do a lot of these autonomous applications and cloud applications. I'll give you some examples. So weather is an easy one. So if there's going to be a weather change tomorrow, the system needs to react and predict that. But there are also other things. It's really surprising how little critical data um, building automation systems have today. I would venture to say that probably 95+%, maybe more, of the building automation systems deployed on planet Earth don't know the price of energy that they consume. Something as simple as that, like what's the kilowatt hour rate or the natural gas rate? So bringing in utility tariff data, utility bill data, grid emissions factors, these are all very valuable inputs into how we can optimize and run our building.
I did not know that that data point. That's alarming, but maybe obvious as well. Thank you for sharing that. So you've talked about those sort of inputs. The next thing I'd like to sort of touch on a little bit is safety rails and governance. So how do you govern closed loop control so write back stay safe, auditable and trusted across the portfolio?
Yeah, this is another important topic. So clearly, when we're doing closed loop autonomous control, we need to have a few things in mind. Firstly, the context. So what are we controlling? Are we controlling a rooftop unit or a chilled water system, etc.? So the nature of the equipment and the mechanical system and its design matters a lot in how these algorithms work. So the guardrails need to be in place. And at BrainBox, we've invested quite a bit of energy and time over the years in building, let's say, agnostic and objective algorithms that observe the actual control algorithm. So we have kind of a referee concept or a judge concept where you're able to say, well, algo A, you're trying to, for example, write to the chilled water supply temperature set point. Is that value that you're sending across, is that objectively a reasonable value? Or does it send some sort of a flag, say, oh, it's too high, too low, etc.? So this concept is critical when you want to have sustained performance and safe performance, to your point, across a wide heterogeneous installed base of equipment. So leveraging that principle and leveraging application-specific or equipment-specific algorithms that are able to understand the nature of the mechanical systems they're connected to, I would say, are critical ingredients.
Yeah, of course. One of the next critical parts of that sort of ingredient is the talent needed to deploy. And so if we think about scaling with scarce talent, we know the industry is short on technicians and experienced operators. How does read and write autonomy change day in the life for operators, and what SOP changes help teams trust and adopt automated corrections rather than watching another dashboard?
I'm glad you brought this up. I find we don't talk enough about this topic, right? So to your point, there's in the US alone an estimated shortage of about 110,000 technicians out of an estimated total of about 420,000 technicians total, according to the US Bureau of Labor Statistics. That's a big deal, right? That means that the 420 are doing the work of 530, or that the work is maybe being postponed or some mix of the two. So shout out to all the facility professionals that are out there making these buildings run like these buildings kind of behind me. This doesn't happen by itself. There are people that are carrying this load and making sure that all of this work occurs. So how can we best support them, right? So this is all about time. So at BrainBox, we focus, how can we save these people who are already firefighting? How can we save them time? So we save them time in a couple of ways. So to wrap up the point on autonomous control, this is a series of activities that reduce the energy consumption of the building while maintaining comfort within the guardrails that we discussed. So essentially that takes that box of tasks or things to remember or watch out for and automates them while preserving observability. The other thing that we found when working with, again, our customers and stakeholders is that there's a need for ad hoc data, ad hoc analysis, so to speak, that is driven by context in the building. For example, somebody calls and says, well, I'm hot on the 5th floor, can you please take a look? What happens today in a classic BMS? The facility manager would have to stop what they're doing. They'd have to go down to the basement or the mechanical room, log into the BMS, pull up that zone, chart the outside air temperature, chart the zone temperature, the damper position, etc., to try and triage. There's kind of an analysis or investigative approach, right? Mm-hmm. And then they say, aha, well, maybe my supply air temperature set point isn't where it needs to be, and then they'll remedy it. This takes a lot of time. It's not that it's hard. It's just the steps of doing what I just described take a lot of time. So what we did at BrainBox, we said, okay, enough of this. We can do better. So basically, ARIA is a product that we launched last year. We were fortunate enough to win a Time Magazine Product of the Year award or Top 100 award. And it's a virtual technician and engineer for your building. So you can say, hey, ARIA, what is going on the 5th floor? Can you analyze? So ARIA will go through and pull all of the relevant telemetry data, because remember, it's normalized. It knows which zones are potentially causing it. It's going to compare the zone temperatures to their set points. It's going to look at the outside air temperature. It's going to look at the same things and then provide that summary of analysis in a plain language. Actually, it can speak 14 languages. Interface for the facility manager to say, I see what's happening. It's my supply air temperature. I'm going to fix it. So this can go from an hour's investigation down to 3 or 4 seconds. And we've kind of shared this with some of our partners and customers as well, and they enjoy those benefits. So those two are, I would say, powerful examples of how we are shaving time or reducing time required to support facility professionals in their tasks in buildings.
Yeah, that sounds like there's going to be a lot of weight lifted off the people that have the opportunity to interact with those systems. One of the things that are important, particularly for people that are cutting the checks, is kind of payback under pressure. What electricity costs are up and labor is up. How do you show payback inside one budget cycle without adding another screen?
Yeah, you said it right. Customers want to understand, what value are you delivering? What am I paying for?
Yeah.
So I think the best practices here on the energy side are to have a measurement and verification driven value reporting. So when I or anyone reports out on energy savings, when we go to a customer, say we saved you 1,000 kilowatt hours, let's say we saved you $1,000 of energy costs, etc.
Yeah.
That has to be backed up by an industry standard method. What I think unfortunately happens often in the market is people use opaque, inconsistent, or both methods to justify their performance, and that sometimes it doesn't come across the right way. So say use an industry standard like IPMVP or ASHRAE 14 to communicate your energy savings.
Yeah.
Don't forget about the emission savings. When we're reducing energy consumption, we're reducing the utility costs, but we are also simultaneously reducing the scope 1 and scope 2 emissions of that building. Very meaningful for company sustainability plans and compliance, as well as communication to tenants and stakeholders that we are doing something better than the average building. And most importantly, it's just better for our environment, right? For our planet. On the ARIA side, we talked about productivity, right? So productivity is a big deal. And what we found is that the lift is so large. People can see like, yeah, I don't know exactly, I don't have a calculator with me, but I can see that using this was going to save me 15-20% in my productivity on my day-to-day tasks once deployed and available to my facility managers and technicians and so on and so forth. So those, I would say, are the two buckets of value that people should be considering.
Brilliant. Well, time has absolutely flown by. That concludes your very valuable insights. I was nodding all the way through, and I'm sure everyone listening will pick something from you. So thank you ever so much for your time.
Thank you for having us. Speak soon.
That was Omar Tabba from BrainBox AI. Here are a few takeaways worth holding on to. 1. minimum viable data layer. Beyond BMS points, tariffs, weather, and grid emissions all matter for real optimization. 2. Guardrails for trust. Closed-loop control needs referees and context-specific checks to stay safe at scale. 3. Talent shortage makes autonomy urgent. With 110,000 US technicians missing, automation is about saving people time, not replacing them. Thanks for listening. Short episodes, sharp insights, no filler. Catch you next time. You've been listening to the Climate Gap Quick Cuts. If you're building in climate tech, subscribe to hear more from the people making it happen.